All right, I got to talk about total internal reflection, which is something that is used in fiber optics. The first thing that we have to talk about, though, before we can actually get to that, is something called a critical angle. And if you look up at the top there, it says at a particular angle when moving to a smaller n value, because moving from a large to a small n value, remember that the refracted ray gets bent away from the normal. At some particular angle, though, that you approach that boundary at, the angle of refraction is going to be 90 degrees, which would put you right along the boundary between the two mediums. So just like in this one, if we've got the incident ray coming in at a certain angle, that incident angle is going to produce a refracted ray that lies right on that boundary. Okay? When that happens, that is known as the critical angle. And if we think about this using Snell's law, if we said n1 and then this would have been sine theta 1, but we're going to call it the critical angle, would equal n2 sine of theta 2, but in this case, since theta 2 is really a 90 degree angle from normal, it makes just 1. Therefore, the sine of the critical angle is n2 over n1. Okay, so that would be if the light would essentially never make it out. Okay, which is sometimes why you can see into a pool just fine, but when you're looking from the bottom of a pool out, sometimes it can be a lot harder to see things. Okay. If you look here, let's say the angle of incidence is actually greater than that critical angle. Okay, if that does occur, we don't get any refracted ray whatsoever. All we get is a reflected ray. So we would have the incident ray coming in, and then at that certain angle, you'd get a reflected ray that obeys the law of reflection. Okay, that is known as total internal reflection. Okay, this is the basis of fiber optics. It has the ability to keep a light ray inside a tube of some sort, usually made out of plastic. Okay, and that's only possible if N2 is smaller than N1. So, going from glass to air or plastic to air, something along those lines, that's when total internal reflection can occur because the second N is going to be smaller than the first N.